So, we are looking into different non-explosive sources. The non-explosive sources are vibrosis, mini source. Right. Vibrosis is one of the common method of non-explosive source, which is used for refraction as well as reflection surveys, right. And this is something like vibrator mode in our mobile phone. So, what it uses a truck mounted vibrators to pass shocks into the ground, right. It is of low amplitude and continuously varying frequency. We can also continuously varying the frequency, which is known as a sweep signal. Vibrosis is quick and convenient to use. Another great advantage of this is we can use precisely known as well as repeatable signal, which is difficult in the case of explosives. Though we may load the same quantum of explosives, the energy that it is going to dissipate may vary, whereas in the case of vibrosis, there is a repeatability possible, right. That means you can repeat the same quantum of energy, you can repeat your investigation. Right. Vibrator unit, however, needs a firm base. That means the ground surface has to be relatively firm. It will not work on the soft ground. It is obvious, isn't it? For the vibrator to be active, you need a firm ground, preferably a tarmac road or a solid ground surface is necessary for the vibrator to work, which you can understand from this picture, right. This is a vibrator mounted on a heavy truck. This is the vibrating pad. This vibrating pad can be lowered or lifted up. During transportation, this will be lifted up, and at the time of our investigation, it can be lowered down. So, the vibrating pad now firmly fix or touches the ground surface, and this entire platform is made to vibrate, both horizontally as well as little bit of vertical impact. So, this is how energy is dissipated into the ground. So, what are all the advantages, right? The greatest advantage is it can be used in urban environment because it causes no damage and also not much of a disturbance to the environment. Whereas, in the case of explosives, you need to get lot of permissions, right? Whereas, when you want to use vibrosis, it can not disturb the environment very much. So, it is easy to use, and as we can repeat the method or we can repeat the investigation number of times, right. This method is very good for correlating of extracting the signal, and it is also coping up with high noise level in the urban areas, right. So, in urban areas lot of noise will be there. Since vibrator you can provide signal by sweeping in different frequencies, the frequencies at which we are energizing the ground will be very different from that of the urban noise. So, this is another advantage of vibrosis. What are the disadvantages? The major disadvantage is the very high cost. The cost of the equipment which we had seen just now is very expensive. So, the method effective for hydrocarbon surveys, the method can be useful for oil exploration, but however, this is cost prohibitive for small surveys. Maybe for civil engineering investigation, use of vibrosis will be cost prohibitive, right. These are the disadvantages of the vibrosis, right. Then the another simple method is mini source. This is nothing but a pneumatic hammer often used in civil construction, right? It is a kind of road compressor, or sometimes we use such a tool to compact the concrete aggregate which we have poured, right. So, we will use something similar to that, right. It is more or less like a road compactor, as you see in this diagram. It will have a small platform and a kind of hammer. It will give hammering, right. A kind of pneumatic hammer will give some impact, right, in vertical direction, right. So, this is how the method is operating. This is useful, again similar to vibrosis. This is useful in noisy urban environments, right, particularly close to roads where there may be heavy traffic. Usually during seismic survey, traffic will be stopped for some time, whereas this may not be possible everywhere, right. So, in such locations we can go for mini source, right, mainly to suppress the noise which we receive, because this method produces noise that is very different from the ambient noise in urban environment. So, in areas of particular or limited access, right, due to certain reasons, mini source can be used as a source. This method itself is functioning like a vibrosis, right, and we can investigate up to a depth of 1 meter using this. These are non-explosive sources of energizing the ground, right. Next, let us see how can we energize the subsurface from the ocean, right. Seismic methods can be carried out on land as well as from water. These are the different sources of energizing the ocean water, right. The energy will go down, and this may be the ocean floor. Energy can pass through the ocean floor, right. So, here we consider the top layer, which is water. The next layer may be earth, that is the ground, right. So, this is how investigation is done from the ocean. So, what you see in the picture is the ORV Sagar Kanya, Oceanic Research Vessel Sagar Kanya, which is written here, which is a ship owned by the Government of India, managed by the CSIR, National Institute of Oceanography. This ship has got all the facilities to carry out seismic investigation in oceans, right. So, these are the different sources by which we energize the ground. Marine vibrosis is something similar to the vibrator which we had seen previously, right, which is very big. Instead of that, we will have a small arrangement of a vibrator. This will be lowered into the sea, right. The vibrator will go and sit on the ocean floor, and from the ship we will be operating this vibrator, right. This is one of the method of energizing the ocean floor. Rest of the methods, we energize the water in the ocean, right. How? Let us see. First is the air guns. Air guns are a chamber, right, which is charged with high pressure compressed air. A chamber is compressed with air. Usually, the chamber will be made to float or towed behind the ship. In some ships, the air gun will be at the bottom hull of the ship itself, right. This chamber, which is stored usually behind the ship, right, in some ship, in scientific vessels, it will be actually at the bottom hull of the ship. This chamber is fed with compressed air through the hose pipe connected from the ship, right. It is stored with some cables to transmit the energy, and also a hose pipe through which compressed air is pumped into this chamber, right. So, after the pressure is reaching to a high level, suddenly the pressure from this chamber is released by a mechanism like a triggering mechanism, electrical triggering mechanism, a press of a button, something like when you press the button at our home, calling bell rings, something like that. When you press the button, the chamber is suddenly released. The air is forced into the ocean water through the vents, right. This creates a high pressure bubble. The high pressure bubble energizes the water. The energy not only restricts itself with the water, but it also goes and touches the bottom of the ocean, and then it starts also entering or traveling through the formation beneath the ocean floor, right. So, this is how air guns are used. The primary pulse generated by a air gun followed by a train of bubble pulses increase the overall length of the pulse. That means, this is the first time we completely release the air, it creates a bubble, then subsequently we can quickly charge the chamber and release the air. It is something like the use of vibrator. That means, you can remain the ocean water charged with a slightly elongated lengthy pulse of vibration, right. Here, the other way of energizing the ocean is by use of water guns. This instead of air guns here, right, compressed air rather than being released into a water layer, it is used to drive the piston and ejects water jet into the surrounding water, right. So, here suddenly water jet is released, right, something like a jet of water into the ocean. This itself energizes the ocean floor. So, this is the top of the oceanic research vessel Sagarkanya. Here is the recording station within the ship, wherein I was part of a cruise in the year 1994. 1 month cruise we had been to carry out multiple investigations in Indian Ocean near Madagascar, right. And here is the picture of the air gun, are more or less the same. Both water gun and air gun are the same, only difference is here air is compressed, that is all, right. So, this is towed, and behind the ship, as you can see here, several air guns are towed, right, and all of them are connected to the ship through a cable as well as hose pipe and also data transmission cables, right, and behind that will be the geophones, right. So, this is a picture of a air or water gun. Then what is pinger? So, pingers are something like high frequency systems which normally use a ceramic transducer to produce acoustic pulses, right. They produce acoustic pulses, right. This produces high resolution image of the subsurface, especially bringing out small features, right, from shallow depth. However, these pingers energy cannot penetrate deeper below the seabed, only up to few meters, maximum 10 meters below the sea level. That also depend on what is the type of sediments and what is the water depth above, right. The pingers are operated from here, right. This is a pinger. So, this generates some acoustic pulses. The acoustic pulses goes and gets reflected from the ocean floor. Part of it also enters into the ocean floor. Reach up to a maximum of about 10 meters or 10 or 20 meters, maximum maybe 30-40 meters. That depend on the type of sediments as well as the thickness of water. Then another method by which we energize is known as sparker. Here we produce a electrical spark, right, which vaporizes the seawater, right, around the tip of the sparker. This vaporized water rapidly expands and produces a wave, kind of produces a pressure wave, right. So, large very high powered sparkers can produce low frequency and which can penetrate even up to 1 kilometer, 1000 meters below the surface, right. Whereas, this is for the large sparkers. Small sparkers are employed for high resolution bottom surveys. They penetrate normally up to 100 meters, right. However, resolution will be very good. So, we will be able to understand even up to 15 centimeters how the lithological formation varied every 15 centimeters can also be understood. So, these are the different sources by which we energize the ocean water to carry out the survey in the sea, right. So, here is a picture, right, same Sagar Kanya vessel, right. As the vessel process, in the case of Sagar Kanya, the transmission of shocks is from the bottom hull of the ship itself. In some normal ships, right, which can also be used for seismic survey, for that we will use the sparkers or air guns will be towed. Behind that will be a long rope which will have the geophones. All of them will float at the near surface of the water, so that the energy is not wasted, right. The buoyancy will be kept in such a way they are very close to the surface of the water. So, as the survey is being carried out, ship can continuously move, right. So, this is how, this is the first shot, second shot, and so on. The ship can move, the next shot may be here, next one, like that. You sweep the entire surface along a profile on the ocean, right. It is something like that. If this is the steady area, you go past and carry out surveying in this fashion. Okay. So, this is how the ocean surface is energized by different sources which we had seen through, right. Then the next is picking up of signals, right, which is the third stage, right. Picking up of signals, that what is the first stage? First is surveying, second is energizing the ground or ocean, third is picking up of the signals. Picking up of signals is done with an instrument known as geophones. Some people call this also as seismometer, right. However, geophone is the proper word to describe the device used to pick the seismic signal, right. To detect the seismic motions, ground motions are picked up by an instrument known as geophones, right. Geophones kept at the surface are actually like a low frequency microphones. The mic which we use, or the mic through which I am speaking to you, or the mic which you use every day, where in your mobile phone, something like that is referred as geophone in seismic industry, right. The major function of the geophone is to convert the mechanical vibration. So, what happens when you transmit, when you energize the ground, the energy goes in and comes back to the surface. This generates some shock, right, both in vertical or in horizontal. Maybe the shock can be measured in x, y, z direction. So, it is a mechanical vibration. The mechanical vibration is converted into a electrical pulse or electrical signal. That is the function of geophone. So, geophone thus basically convert the earth's vibration into electrical signal. This is achieved generally by the movement of magnet with respect to coil surrounding that, right. So, what we do is we have a magnet, right, which is freely hanging as the pen which I am showing to you now, around a coil, right? As the magnet moves up and down during Earth's vibration, because the Earth will vibrate this way. So, this magnet also moves within the coil. This produces some small electrical voltage, right? But different manufacturers arrange this in a different manner, right? They claim their product is the best, right? That means here is a simple picture, right, where you have a magnet at the center, right, surrounding that is a electrical coil. You can also reverse, right? That means magnet can be fixed, coil can be made to vibrate. So, in this case you can see there is a spring. The magnet is hanging in a spring. So, what happens? The bottom also will be tied, so that magnet does not oscillate and go and touch the coil, right. But these are all springs, right. So, depending upon the Earth's vibration, the magnet goes up and down. Magnet vibrates during the seismic survey as soon as you pass the energy into the earth, or as soon as the energy is received by this particular geophone. This movement generates some electrical signal which is tapped. Okay. Very simply, this is the function of a geophone. So, however, there are many companies which produce geophones. Some geophones are capable of also recording the vibration in all the three principal directions. Many of them, simple ones, measure the vibration in a vertical direction. So, this is the function of a geophone. So, as I told you, geophone consists of a magnetic mass fixed to a container, right. The coil is surrounding that, right. Coil is surrounding that, right. So, this is how geophone functions. Usually, vertically suspended systems are very sensitive to vertical motion. What is vertically suspended? That is what we had seen in this picture. So, it is a vertically suspended system, right. These are the common geophones, right. Horizontally suspended, that means here the entire setup will be, it is suppose if you turn it 90 degrees, that is the horizontally suspended. At the bottom of the geophone you have a spike. Why do we have a spike? The geophone should properly pick the signal. So, it is not advisable to keep the geophone on the surface just like that, but we used to keep it spiked. That means you give a hit, or maybe with your hand you insert the, or you can with your leg, right, you can just stand on that, so that the entire spike goes into the earth, right. This is the earth surface, so that earth has proper connection with the geophone, right. And the frequency of vibration that simulates the strongest geophone response is known as natural frequency of the geophone, right. Natural frequency is obtained from the response curve. That means, what is response curve? We will study the vibration that is received by all the geophones that we have used during a survey, and we identify what is the natural frequency from the response curve. That means, how the geophone responds to the vibration that it receives, right. In fact, response curve is nothing but a plot of electrical current output, right, measured from a geophone, measured for different vibration frequencies. For example, if you are using vibrosis, it is very easy to prepare the response curve, because you can give vibration in different frequencies using a vibrosis method. And for different vibration which you had given, right, what is the electric current received, and what is the frequency of vibration. This relationship is known as response curve, right. So, this is how geophones are used in the field. So, basically very simply I would like to repeat, geophone converts the mechanical vibration into a electrical signal. Right. Then here is a picture of an actual geophone, right. Here is a geophone which has not yet connected, right, which is very ready to be connected, right. And geophones comes with a nice clamp arrangement, right, something like this. You can see the clamp, two ends of the geophone which is connected, which will be clamped here to the cable, right. So, the cables are manufactured in a nice way. So, so that the the geophone's clamps can be just plugged into it, right. That means here not yet connected, this will be something like a kind of a clip which we use, right, something like this, right. When you tighten it, this will expand so that you can insert that into this. So, here is the connection, right, here you can see the live wire, right, and this spike is here, the top is blue color will be at the top. We used to press the blue color so that the spike goes into the earth, right. You can understand the size of a geophone, which is a very small equipment. So, I had kept my pen here to understand the scale. So, the entire length of the geophone will be equivalent to that of the pen which we use. So, it is a whatever we had seen previously, everything is housed within the small thing, so that it is easy to carry the field, right. And the cable to which we are attaching, right, suppose you are using a cable which is capable of connecting 24 geophones, right. The cable will have how many wires inside? It will have 48 wires, isn't it? Because every geophone signal has to be taken separately to the recording unit. So, cables are very expensive, it has to be properly maintained by us, right. Suppose if you want to deploy 48, then this 24 is connected here, the entire signal will be tapped and recorded here, there will be a recording unit, then you will have the next length of cable, right. Maybe for 24 geophones, then you will have one recording unit. So, this is how connections are made. So, it is like a kind of, how can we say, a compartmentalized system, right. Suppose if you want to use 128 geophones, 24 to multiples of 24 we will use, right. So, this is how many number of geophones can be used to listen to the vibrations of the seismic waves produced from the source which we have generated. Here you can see a cable, geophones are ready to be inserted into the earth. Now, here you have a complete setup, right, of all the geophones which are ready to be connected to the or pushed into the earth.